Again, good morning to everyone. So, in this webinar, I'm going to explain about getting started to DevOps. Okay. So, myself is Jerish. I'm senior cloud and DevOps trainer in Ekascloud, and I'll be handling this session for the day. Okay. So, the agenda for today's session is I'm going to explain what is DevOps, why DevOps, and roadmap to become a DevOps engineer. Right. So, this is what we are going to discuss. Okay. See, before I explain what is DevOps, I'm going to tell you a few things about software development lifecycle. Okay. So first of all, we'll start with what is software development lifecycle. What were all the some older or traditional methods used, and then we will understand what is DevOps. Okay. Okay. So let's say so this is a supermarket. So they want a website and an application. So they are contacting a IT company. Okay, let's say this is a software company. So this supermarket is contacting this software company for developing a website or an application. Okay. So normally within the software company, in any software company, there will be lot of teams, but mainly there will be two teams. One is developers. So developers are the people who write code, do the development, build the application. Okay. So they are the one who write code and develop the application. And operations, their responsibility is to deploy the application on some servers. Okay. It can be on physical infrastructure within the premises, or it can be on cloud. Okay, let's say this is cloud. So the responsibility of the operations team is to sometimes deploy the application on some physical servers, or sometimes creating a virtual computers within cloud and deploy the application and make that application available to the end customer. So who is the end customer? Supermarket asked for the website or application to be developed. So this software company developed the application with the help of developers, and this operations team, they deployed the application on physical server within the premises or on cloud, and they made that application available over internet to end customer. End customer means general public. So people who access the supermarket's application, they are end customers. Okay. See, lot of things happen from the beginning to the end, right? So this process is actually called software development lifecycle, SDLC. So have you understood what is software development lifecycle? Software development lifecycle means from the time this supermarket asked the software company to develop the software, then developers worked on writing code, then operations team deployed the code, and operations team made the application available over the internet, and the end customers were accessing that application. That is actually called life cycle of a software, right? That is called software development life cycle. Have you understood what is software development life cycle? Any questions?
Yes, sir. Yes, sir.
Okay. So what is software development life cycle? SDLC.
It's a full cycle, right from the beginning, the supermarket or whatever who wants, and approaches the customers, software developer, and then the deployment and end of deployment. It's the whole cycle is called the software development.
Yes. Okay. See, in a large enterprise or maybe in a smaller enterprise, this is not done by a single person, right? It will be done by a lot of teams. Even though I said here developers, operations, but it's not only developers, operations, lot of teams involved to complete this cycle. Okay. So traditionally, there were some models followed by enterprises. Software development life cycle. There is a lot of software development life cycle. Even I don't know some, right? But traditionally, before 10 years, 15 years, or maybe 20 years, um, when IT companies started to do these business, right? There were some models like waterfall model. Waterfall is actually a software development lifecycle. Okay. Right now, first of all, I'll explain in a high level what is waterfall model. Okay. Right. So hope everyone understood what is software development lifecycle. I'm going to explain what is waterfall model. Okay, in a high level. The aim of today's webinar is to understand what is DevOps and why DevOps, but I'm explaining some information related to waterfall. Okay. So maybe in your college days, you might have learned this model. It may be there in software engineering, right? So waterfall model has various phases. Okay. So requirement phase, then design phase, then development phase, then testing phase, deployment phase, and finally maintenance phase. So what is this phases? These are different phases in the development of software. Have you understood? So now what is requirement phase? What is requirement? See. So in this software company, there will be a business analyst or some solutions architect. They will be the one collecting the details about the software, what product has to be developed, right? That is actually called the requirement phase. Okay, so which means requirement phase is gathering the information about the software, and who will do it? It will be done sometimes by the business analysis team. Okay, right. So that is actually called the requirement phase. Have you understood what is the requirement phase? Requirement phase in waterfall lifecycle is, so the people, which means the solutions architect or the business analyst, he will be the one, or maybe the project manager, he'll be the one talking with the client. So in our case, in this drawing, the client is the supermarket. So he'll be the one talking with the supermarket about the requirements, and he will gather the information. Okay, that is requirement phase. Have you understood? Then once after the requirement is gathered, then design will happen. So there will be, again, within a company, there will be system architects or solution designers. So they will be the one designing how the software has to be. Okay. So once after getting the project, so these systems architect within the company, they will be the one designing how the software has to be. Okay. And they will give those informations to the development team. So which means immediately developers, they don't start writing the code. So first, some business analyst will gather information about the requirement. Then system architects will design how the product has to be. Then it will be given to the developers, and developers will sit and write the code. Have you understood? That is the development phase. So the third phase is development. Okay, so let's say developers have developed an application. Okay, let's say lot of developers worked in a collaborative way and they developed an application. Okay, now this application has to be tested. So there will be again another team called testing team or QA team. Okay, so they will be the one doing the testing, whether there is any bug on the software, whether the code is correct or not. So they will be doing a lot of testing. Once the testing is done, it will be deployed on some servers. Okay, so the operations team, they do the deployment. So if it is on some Windows machine, it will be Windows team, they will be doing the deployment. If it is on Linux machines, it will be Linux team, they will be doing the deployment. I understood. Once the deployment is done, again, the operations team's responsibility is to make it available over the internet. Which means if it is within the premises, the network team will make the application available over the internet. If it is within cloud, it's the cloud engineer's responsibility to make the application over the internet. Have you understood? And finally, after deployment, the work is not over. So again, there will be system engineers, they will be keep on maintaining the product. If there is any bug, they have to fix it, right? This is actually called software development lifecycle. And this phases, what I have written here is actually waterfall model. This is a model traditionally followed by enterprises. Have you understood? Have you understood?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay. So hope you have understood what is software development lifecycle and what is waterfall model. Now, this model, I told you it is traditional, it is older, it has some challenges. The challenges, let me explain about the challenges in this waterfall model. Okay, see, I told you here. So this is done by business analyst. Here system designers will be there. Then developers will be here. Testing team will be here. Then operations team will be here. Okay, they will be the one doing the deployment. So which means various teams worked in different timelines to develop a product. Which means, so if this supermarket is asking this software company to develop an application, different teams work on that on different phases, different timelines. Maybe after 3 months, they will make a product and they will give it to the customer, or they will make the product available to the general public. I understood. Which means here in this waterfall model, the time taken to deliver the software is slow because different teams involved in this and different teams worked on different timelines to complete the product development. Have you understood? So the disadvantage on this model is time taken to deliver the product is slow. Okay. And because different teams involved in different timelines, let's say the business analysis team got the details from the customer, system designers were designing it for like around 1 month, developers were spending like around 2 months to develop the application. So let's say here you have completed 3 months. After 3 months only, you will be doing the testing. Testing will maybe happen for 1 month. I'm just saying. And finally, deployment will happen for 1 month or maybe 2 months, right? So time taken to deliver the product will be slower in this type of methodology, right? In this waterfall methodology, time taken to deliver the product is slow. And sometimes, let's say at the beginning, let's say when this supermarket given some requirements at the beginning, they said they want the product like that, like some they should have some designs like this. So after 3 months, if they have a different requirement in this waterfall model, you can't do it because after 3 months they'll do the testing. So this model cannot accommodate changing requirements. If clients have different requirement after a few months, again it will take a lot of time. I've understood. So that's the reason, that's the disadvantage with this waterfall model. So the disadvantage with this waterfall model is time taken to deliver the product is low. Why? Because different teams involved to develop the application and different timelines. They worked on different timelines. Because they were working on different timelines, and it cannot even accommodate changing requirement. If there is a changing requirement from the client or the customer, again, people has to rework. Again, it will take time. Have you understood? So which means mainly there is two disadvantages. One is time taken to deliver the product is slow, and two, cannot accommodate changing requirement.
Yes, I clearly understood. This is a traditional method, waterfall method.
Yes. So have you understood? Any questions? So if you have any questions related to whatever I have explained till now, you can ask. So first of all, I explained what is software development lifecycle. I said from the time the client asks to develop an application till it goes to the customer, whatever happens is actually the life cycle of the software. Traditionally, companies were following a methodology called waterfall, and I explained waterfall model. Waterfall model has various phases, different teams involved in different timeline to develop the software. Because of it, time taken to deliver the software is slow, and because of it, it cannot accommodate changing requirements. Have you understood?
Understood, sir. Yes, sir.
Yes, understood.
Okay. So a lot of companies, they moved from this model to a different model. See, still some companies may use it. Still some companies may use this waterfall model. But if you want to use waterfall model, you need to know everything upfront. You should have proper documentation upfront. And if you have a perfect idea of what you are going to do end of 3 months, then you can go with this model. Okay, but if you have a product which has lot of changing requirements, then this model is not suitable. Have you understood?
But whatever it is, they have to understand the requirement of the customer.
Yes.
It's very important, and also based on that only they can quote out.
Yes. So here, because it is on different phases, it is not easy to go back to the previous phase. That's what it's called waterfall. Okay, it is compared to the real waterfall. Okay, maybe the falls. Once the water is flown down, it cannot go back. All right. Okay. Now, see, clients sometimes have always changing requirements. So maybe first of all they will say that they want some application. Then after a few months, they will say that in that application the design has to be different. They have to add some new tabs in the website, something like that. They will keep on giving lot of requirements, which means developers, they want agility. So they want to keep on developing and improve the product. But operations team, they don't want to keep on making changes on the application, because if it is a operations team, he might have configured some servers, he might have deployed the application. If he's keep on making changes to the application may go down. Okay, which means developers, they will keep on making changes to the application because of client's requirement. Operations team, they can't really keep on making changes to the application on a running server. If they keep on making changes, sometimes it may go down. Have you understood? So then there is a different model developed. Then there is a different software development lifecycle model developed, that is called agile model. Okay. So now I'll explain about agile model in a high level. Okay, so there can be separate courses on it, but I'm just going to spend 5 minutes explaining what is agile. Okay, so people started to move from waterfall model to agile model. Still companies are using this model. Okay, now how it works? See, the entire project, let's say if it is 6 months, okay, if it is 6 months, around 6 months, it will be broken down into smaller phases. Okay, smaller sprints. So the requirement will be gathered from the client, and design, development, and testing will happen maybe for 2 months. Okay, this considers one sprint. Okay, so requirement is gathered from the client, design, development, and testing, it will be happening. This is actually, we can call it as phase one. So phase one happens in a short period, for example, 2 months. Okay, once it is done, it will be given to the deployment team, and that application will be deployed on some physical infrastructure, physical servers or on cloud, and it will be monitored and maintained. And then again, if the customer is giving feedback on the application, again there will be design happening. So which means on the first phase, you may not have a complete application, but you will have the application. You will get feedback from the customer. Again, you do design, redesign. Again, you do improvements. Again, you do development. Again, you do testing. Again, you do deployment. So this is actually called agile model. Okay, so let's say this is phase one. This is phase two. And it may be in multiple phases, depends upon the size of the project. Have you understood? Okay, let's say first phase is for 2 months. Second phase is again for another 2 months. First 2 months, you had an application. You get feedback from the customer. Again, you do design, development, testing. Again, you get feedback from the customer. Again, you do design, development, testing. You can have multiple phases, depends upon the size of the project. Now, by doing this, by adopting to this methodology, so what is improved? Development is becoming continuous, right? The design, development, and testing, it is continuous. For every 2 months, it is happening, right? See, I'm just saying 2 months, but it can be for different. Sorry, it can be different. Okay, right. So here in agile methodology, the development is continuous. Okay, but deployment, sometimes it's not continuous. It happens at the end. Okay, have you understood? Have you understood what is this agile model? Agile is another software development lifecycle. Instead of doing the entire project for 6 months, here in this model, the project will be broken down into multiple phases or sprints, and developers work for short phases and they give the product to the deployment team and they do the deployment. So I told you the development becomes continuous. They will get feedback from the customer and they will keep on doing development. I understood. But still, in both these models, actually there is a gap. Okay. So there is a gap between developers and the operations team. Okay. So actually up to this development testing, we can call it as developers team. And this deployment and maintenance, we can call it as operations team. There is a gap between developers and operations. Developers works in a different timeline. Operations team work in a different timeline. This is one. Here as well, in agile model, developers works in a different timeline. Operations team work in a different timeline. This is one gap. The another gap is developers knows how to do the coding, but the deployment team or the operations team, they don't know how to do the coding, right? Developers know how to do the coding, but the deployment people, they don't know how to do the coding. In both this earlier, traditionally, I'm saying because it was like this, what happened is, let's say the developers have developed the application, they might have did the testing in their local computer or in some system. And once it is done, they will be giving it to the operations team. Operations team, they don't know how to read the code. So what they will do, they will do the deployment on the server. And sometimes if it is failing, operations team will blame the developers saying that the application is not properly developed. Have you understood? Which means operations team will blame developers team that application is not properly developed. Developers will say that it is perfectly working here. They will blame the operations team that they can't read the code properly. They can't properly deploy the code, right? So there will be blame game happening between the developers and the operation team. It still happens sometimes, but this happens in a lot of enterprises. Have you understood? Anyone faced when you're working? Hear me? Can you hear me? So
Yeah, clear.
yes, right. So there will be blame game happening between developers and operations because they are working on different timelines. And developers knows how to code. Operations, they don't know how to code. They know how to do the deployment, but developers, they don't know how to do the deployment, right? Okay. So because of this blame game as well, what is happening? Ultimately, the software deployment becomes late, or software delivery to the customer is becoming late, right? So developers, they will give the application to the operations team and they will think that their work is done. Operations, they will try to do the deployment, it will fail. They will blame the developers that the code is not working. But at the end, what is happening? The product is not delivered to the customer. It is becoming late. So again, developers has to work separately. Again, operations team has to work separately, right? I understood. So this is the problem with the traditional model, okay, waterfall model as well as agile model. So you might have understood already, right? What is DevOps, right? So I told you the agenda for today is to understand what is DevOps, right? And why DevOps. Now, what is DevOps? What is DevOps? Actually, a lot of people will think that DevOps is a software. No, it's not a software. A lot of people will think DevOps is some protocol or something. Okay, so today you might have perfectly understood that DevOps is a software development lifecycle. It's a methodology. Okay.
Like a combination of development as well as operation.
So the dev part is actually means developers, and the operation ops part, it means operation. So which means DevOps actually combines both developers and operation and to work together. Because both developers and operations work together in modern day, I told you some gaps were there, right? What is the gap? Knowledge gap, maybe timeline gap. Those problems will be fixed in modern day enterprises where DevOps culture is used. Okay, which means DevOps is actually a methodology used by enterprises where both developers and operations team work together to develop a product. Because they are working together, they deliver the product to the customer in a faster way. Have you understood? Have you understood what is DevOps?
Yes, sir.
Okay. So if I go here, search for DevOps. Okay, it says here. So DevOps is a culture and collaborative mindset. Okay, I told you already, collaboration will be there between mainly developers and operations team. Okay, it says it combines software development, which is the development part, as well as IT operations, the ops. The aim of DevOps is to deliver the software faster and more reliable. Okay, traditionally there were problems. The time taken to deliver the product is slow. But because of this culture, new culture, DevOps, so both team work together and they deliver the product to the customer in a faster way. Have you understood? Which means, see, there can be some companies, they may not using the DevOps culture. They may be still using traditional waterfall model or agile model. Maybe there can be some companies, they may have already adopted the DevOps culture. By using the DevOps culture, they may be delivering the product to the customer in a faster way. Okay. Let's say, I'm just saying, okay. So let's say there is a company ABC. They are developing a supermarket application to one supermarket. If they are using waterfall model and if they are taking 6 months to deliver the product to supermarket, and let's say there is one other software company, XYZ, they are using DevOps culture, they may be delivering the product to the customer in a shorter period, maybe 3 months. Okay. So, which is good. Giving the product to customer in a faster way, right, in a short period is actually good, right? So, what customers will do? Customers will go to companies, enterprises, where they develop products in a faster way, as well as they develop product according to their requirement, right? Have you understood? Now, DevOps also has various phases. See, if you search for DevOps and if you go to images, you always see this infinite loop symbol, right? This loop symbol means that it is continuous. Okay, I understood. So this is all again phases of the software development. Okay, so there will be planning done by the business analyst. Then there will be coding done by the developers. Whatever they have coded, whatever the developers have developed, it has to be built. Build means, see, when developers are developing the code, the files will be separate. There will be different developers work in different laptops, desktops, and they build the product, develop the code. It has to be integrated. It has to be built as a single software. Okay, that is called build. Then after the building, that software has to be tested. Okay, and after the testing, it has to be kept in some place, repository, that is called release. And from that place, it has to be deployed on some servers. So we see, maybe most of you are attending cloud courses with me or with other trainers. You are already doing sometimes. You are creating virtual servers. You are deploying applications, which means you are already working on one phase. I understood. You are not doing the coding part. You are not doing the building part. You are not doing the testing part. So maybe you are doing the deployment part and operation part, right? I understood. Now, in this DevOps culture, what happens? Actually, everything become continuous. Okay. Now, how everything become continuous?
I didn't get you, sir, your question.
Okay. So I said in DevOps, everything become continuous. Okay.
Okay.
Which means continuously developers will work on writing code. Continuously build will happen. Continuously testing will happen. Continuously release of software will happen. Continuously deployment will happen. Continuously it will be operated and monitored. Again, continuously coding will happen. It's not waiting for 2 months, again do the new feature. It's not waiting for response from the operations team to do the development. It's not like that. It's not getting the feedback from the customer and do the fixing, right? Everything will be continuous. Now, how it will become continuous in modern day? So in DevOps, there is a lot of DevOps softwares, tools, okay, which means modern day, the companies who are adopting to this methodology, what they will do is they will use some softwares which can be commonly used by both developers and operations team. Have you understood?
Understood, sir.
I have already explained what is DevOps. The aim of DevOps is to speed up the development process and deliver the product to the customer in a faster way. But how it happens, how it can be done? So in this various phases, various softwares are used by enterprises to speed up. It's not human sometimes. Yeah, humans also will be there. Okay, for sure, people know about that products, will work on it. Okay, so humans will also be there, but mostly softwares will be playing major role. Okay, lot of softwares will be tightly integrated between each other on a product development. Have you understood? You can see some drawings. So here it says various software names, right? I'm not going to confuse you with all these names, but ignore it. Okay, I'm just saying in various phases, different softwares are used. Have you understood? Now,
Yes, sir. Clear.
Sir.
see, I'll tell you how it is solving few problems. Okay, which is slowing up the delivery of the product. Okay, see, traditionally there was lack of communication. I told you already, lack of communication means, so in traditional methodology, so developers, they know how to code, they do the coding, they develop the application, give it to the operations team. Operations team will try to deploy the application on some servers, and if it is failing, they don't know sometimes about the code. They need to again depend upon developers. I told you they will blame the developers that they haven't done properly, right? This I'm calling it as lack of communication. Okay, so which means developers knows how to do the coding, operations knows how to only do the deployment. They, because they are not from development, they don't know how to go through the codes. Okay, now this problem in DevOps is actually solved with the help of modern day softwares. There are softwares used by both teams, developers as well as operations team. Okay, for example, there is a software called Docker. This software is not only for developer. Both developer and operations team can understand and use it. Have you understood? So Docker is a software. I'm not going to explain about what is Docker in detail. We will have a separate webinar about Docker in upcoming session. But I'm just saying Docker is a software within DevOps. It can be used by both developers and operations team. Okay, then there is no blaming game. They can't say that it is working here, it is not working there, because it is developed for both the software developers and the operations team, which means these types of products within DevOps, example like Docker, can be used by both developers and operations team. Have you understood? Which means the lack of communication problem, traditionally what it was there within the waterfall model or in the agile model, is fixed in the DevOps. Have you understood? This is one challenge. How it is fixed? Because the modern day softwares are designed not only for developers. Modern day softwares are developed for both developers and operations team to work. Have you understood?
Yes, sir.
Okay.
Yes, sir.
So because it is developed for both developers and operations team, the speed of doing something, the speed of developing the application and delivering to the customer will become faster. I told you already, DevOps, the aim of DevOps is to speed up the delivery. So the modern day softwares like Docker, it will speed up the delivery. So developers work on the product, operations team also work on the same product. So the product will be delivered faster. They can't say that it is working here, it is not working there. Right? So the issues will not be there. Yeah, I'm not saying there won't be any issues, will be there. Still there will be issues. people who learn about those technologies, they will know that what issues they will face. But there will be issues, but it solves some problem. Have you understood? Okay. And coming here, see, here developers and operations team, they are not working on different timeline. Sometimes everything happen continuous. Okay. So let me write here, draw here. Code build test. Release. Okay, so this is the phases of DevOps, right? Okay, now let's say here in this coding phase, developers will be here. They will be the one writing the code. Okay, once the coding is done, they use some softwares. Okay, so once the coding is done, immediately the software will be built. Okay, which means there are some softwares used in coding phase like GitHub. Okay, so these are some of the softwares in DevOps used by developers. And once the coding is done, the code is immediately pushed to some central place called repositories, and there will be softwares like GitHub Actions to immediately do the build, which means this software Git will be integrated with GitHub Actions. So developers, they do the coding, they send it to a place, automatically build will happen. And this softwares will get integrated with again some testing softwares. For example, Selenium. So once the build is success, automatically the application will be tested with the help of some testing softwares. Which means, okay, so developers, they are writing the code and they are just pushing the code to some place. Automatically, the code will be taken and built as a software. Automatically, the code will be tested. And automatically, once the test is succeeded, it will be placed in some place like repositories. Okay, it will be released. Which means here the process is continuous. Okay, this we call it as continuous integration in DevOps. Continuous integration. Continuously development happens, continuously build happens, continuously testing happens, and it will be placed in some repositories. The software will be placed in some repositories. Have you understood? Have you understood what I'm trying to say? So it's not sometimes humans do the building in modern day. It's not humans do the testing modern day. Multiple softwares will be integrated. So once the developers develop the code and they just push the code to some central place, automatically build will happen and automatically testing will happen. Which means continuously this process can happen. We call this as continuous integration. Right?
So repository means it is like a bank locker to store some successfully run the codes, right, sir?
Yeah. No, it's not like that. To keep the softwares in the place. See, normally when we are downloading some softwares, the softwares will have different versions. Version 1.0.0, version 1.0.1. These softwares will be normally kept in some repositories first.
Okay.
Before it is going to some servers. Okay.
But it will not be total, they will be developing the assignment means they will be developing a small portion like that.
They will be doing separately, but even though they develop separately, maybe they can even do it for every day. Every day they can push the code. Every day build may happen. Every day test may happen. Every day release may happen. Okay, in this DevOps culture. See, I told you traditionally it takes months to do the development and then it will be given to the testing team. But in modern day, it's like everyday developers can actually push the code or change the code, and the softwares will every day do the build, and every day it will do the testing. I've understood.
So is it like versions, sir? So they start by like
Yeah,
releasing the
it
bare
can be
bones
like,
first, and then they keep improving upon the bare bones.
yes, it's
Okay.
not for a major version. This everyday changes is maybe for some smaller features.
Okay. Okay.
Okay, let's say in the front end page, if they want to just change something, color or maybe some add a new tab, that can be done today and it can be added to the code. It will do the testing. It will do the it will do the building and it will do the testing, right?
Okay, sir. Yes.
So which means traditionally, because it was done by two different teams, developers and testing team, now this is all done by softwares. This is faster. Okay. And in modern day,
Sorry,
yes,
Zirish, one question.
yes, yes,
Like development in the sense, as we are back from a legacy background, so we used to do the coding in COBOL, everything. So how the developing is happening in this GitHub?
actually, I haven't given any demo. Normally, development happens in every developer's individual laptop. Okay. And the code will be sent to a central place called GitHub. GitHub is a place where normally developers keep all the development code. Okay.
Yeah, I want to know like the interface between the GitHub and the coding software.
See, it's interface means, see, if you go to github.com, so this is how the code repository looks. Okay. You can create your own account here. This is not the only place. This is one example. Okay. So this is a place where you can have your development code. This is the interface. And from the developer's point of view, it's the individual developer's laptop. So for example, if I am a developer, this is my local machine where I will normally do the coding. So I may use some Visual Studio Code like application. I do some development projects. Okay, I understood. So I do the coding
Okay.
from my local computer. Okay, from my local computer. Once the coding is done, it will be sent to some central place like this GitHub. See, for I didn't really plan for any demo for today. I just theoretically want to tell you what is DevOps and why DevOps, right? But in some upcoming session, maybe I can give you some demo on how individual developers' laptops will be integrated with some code repositories. Okay.
Okay.
Sir, can I ask you one doubt, sir?
Yes.
Suppose if I am creating a code to launch a web application in my laptop, and I am creating a container in AWS cloud, and I am using GitHub to deploy the web application, will it work? Like how would this system work? Like I create the code, I save the code in container, then I use the GitHub to deploy the website, correct?
Yes, we can do that. It's not GitHub do the deployment. It will be some other software do the deployment. Okay. GitHub is a place where you will have the developer's code. For example, see here,
Okay.
if I go to my account, so if I go to this Fruitables, see, a lot of time in our course, we used the Fruitable website, right? So the Fruitable website is actually in my GitHub repository, right? This is the one we used a lot of time in our AWS course, right? I understood.
So
From
once I
here,
create the code, I store the code in GitHub. Am I right?
GitHub. Yes, yes.
Okay, fine.
Okay.
Can
Okay.
be
So
accessed by the software or all can access.
it depends. So I kept it public. Anybody can access. But if I keep it as private, only within the company, people can able to access the code. Okay. Sometimes some applications will be public. Even I can show you there are lot of popular applications which are public. So you know about Chrome browser, right? So you can search for Chrome browser, Chromium. Okay, you can see here that Chromium browser's entire source code is in GitHub. It is public. It is kept public. Okay, so Chromium browser's entire source code is here. It's done by a lot of developers. It's not done by a single person. It's done by contributed by 3,529 people, right? And here you can see some releases. There is 34,614 times they have done changes, releases. So there will be different versions. So normally we as a general public, if we want to download the Chrome browser, we just download the version 139.0 point something, right? But in the backend, you can see here, this is a place where you can see various versions of application developed, right? Okay. Yeah, stick
So
to the
once
basic.
just I'm asking just one thing.
Yes.
Once the final version is updated, okay, this is what exactly the customer wants and it is deployed with all the changes. Why do we need so many kinds of versions? Like previous versions, we don't need anymore, right?
Yeah, we will not need it. It's still there. The previous version is there. But sometimes the latest version may not be always the stable version. Latest version may have bugs, security issues. Later they will
Okay,
find.
in case of necessity, they will access the previous versions. Understood.
Yes. Okay. So hope this is clear. This process is actually called continuous integration. What is continuous integration? So frequently integrating your code to some repository, maybe multiple times in a day. And when multiple times, if you do the integration of code, that code will be automatically built and automatically it will be tested. Okay. And earlier, very early, it will detect errors. The testing immediately it will detect error, and it will sometimes if the testing is failing, so the software will automatically give the response to the developers. So developers can again work on it. So that's what this process is very fast. I understood. So they are doing the coding, they are pushing the code
the release will be done by the software itself or the person who is developing it.
relay. I didn't get you what?
No, this is being tested and then released to the repository, the software.
Yeah, if it is success, it has to be configured in a way that if it is succeeded, it will release it to the release repositories. Or if it is failing, it has to send some notification to the developers. Okay. In that way, they are getting the feedback in a faster way, and they will again work on that particular code, right? So traditionally, it was done by two different teams. Developers, they work in different timeline. Testing people, they work in a different timeline. After that, they will give the feedback to the developers. But now in modern day, it's all done by softwares. Okay. Right. So this process, I told you, it is actually called continuous integration. And once the software is here, it can be manually deployed to some servers, like we were doing a lot of time in our AWS course. Right? We can do manually deployment to some servers, or it can be again automated. Deployment of application can also be automated. Okay. It can be done with some softwares like Ansible, Kubernetes. It can be in cloud, it can be managed with some softwares like Terraform. And it can be monitored with the help of some monitoring tools like Nagios. In cloud, it's CloudWatch. Okay. Have you understood? Right. So which means once the product is developed, we can do the deployment manually, or here as well, we can integrate some softwares like Ansible, Kubernetes, and we can deploy the software in some environment in an automated way. Which means developers, they sit and write some changes, they push it to the repository. That's it. Once they push the code, automatically build will happen, automatically test will happen, automatically deployment softwares will deploy to the production environment. Have you understood? So everything becomes continuous. So this is continuous integration of code. And if it is continuously, the deployment is done, we call that as continuous deployment or continuous delivery. Every day delivery may happen, every day deployment may happen. Have you understood? See, I'm not saying for all projects it will be happening. For some smaller features, smaller changes, continuous deployment will happen. Have you understood? Okay. Right. See, and third, see, I told you about lack of communication first. That is solved. Then I told you that there is a lot of integrations. Okay. Because of that, it is speeding up the process. And finally, I'm also saying a lot of coding or automation is done. Okay. See, I'll just finally give one example and then we'll finish. See, traditionally, the deployment or maybe some process is manually done. Okay. Let me take operations as an example. Let's say you want to deploy an application. So what you do, you normally log into the server. You need to type the commands one by one, and you need to manually configure the application. That's manual process. Maybe for the first time it is okay, but if you keep on doing the same, sometimes human may make errors. Okay. So for example, maybe in AWS Cloud, if you are creating your own network, VPC, subnets, route table, everything. For the first time, it's okay. If you are asked to create 20 times, you are repeating the same, which means you are wasting a lot of time in manual work, right? So if whatever you are doing, if you are doing it in a automated way with the help of coding, then you are saving a lot of.
So, hello.
I hear me.
Yeah.
I think there was
Yes,
some
sir.
problem.
Okay.
My network went down. Okay.
I thought
I continue.
okay.
Okay. Yeah. See, what I was saying is, lot of automations are used in the DevOps environment. Okay, so the softwares like Ansible, Kubernetes, Terraform, it's all about writing code and doing the process in an automated way. Which means even in the operation side, people start to write code, but it's not traditional development like code. It's a human readable uh, configuration like code. Okay, so it means even in the operation side, traditionally 10 years back, operations team, they don't care about coding, but in modern day, operations team, to do the activities in a faster way, they are doing coding, but it's not with the help of programming language. It is with the help of some human readable data serialization languages. Okay, so I worked on Ansible a lot. I worked on Terraform a lot earlier. So I know how it is. Okay. So um, right. So which means people used to write lot of code, and if they are doing some repeated activities, okay, if they are repeatedly creating multiple time VPC, instead of going to console and manually creating it, if you write the code and run the code, it will create. I've understood. In that way, you are speeding up the process, right? I've understood. Okay. So hope all this is clear. So whatever I have taught you today, actually this is enough. See, I told you my aim for today's session is just to tell you what is DevOps and why DevOps. Hope you might have understood what is DevOps and why DevOps. Maybe if you are planning to become DevOps person, DevOps engineer, I'll tell you what you have to learn, what you need to know, right? Some information related to it. Right. So I hope everyone have understood what is DevOps. Yes or no? Have you understood what is
So what,
DevOps?
what, what is the job of the DevOps engineer? Because DevOps is, I thought it is a system. What will be the nature of the job of the DevOps?
See, work on various softwares here. Right. In DevOps, I told you there is different softwares. Like maybe sometimes DevOps person may come from development background. DevOps person may come from operations background. So maybe sometimes if you are in a company, you as a DevOps person work related to more operations related tools. For example, I like that. See, I'm not a developer, right? In my entire career, I never worked as a developer, but I worked on products like Ansible, Terraform, Kubernetes a lot. So which means some people, they work on some deployment related or operations related DevOps tool within a company. Like they work on softwares like Ansible, Kubernetes, Terraform. Sometimes some people working in production environment, coming from development background, they work more related to GitHub Actions, Selenium, or various other softwares are there. See, these are some of the softwares which I have told you today. But these are not the only softwares, okay? Today, I just gave some names like GitHub Actions, Ansible, Kubernetes, Terraform. But there are a lot of softwares. Maybe different enterprises will use different softwares based on the requirement. But every company's aim is to speed up the process of the software development. I understood. So which means what they do in their day-to-day life, maybe as a DevOps person, DevOps engineer, sometimes you work on some softwares, you write code, or sometimes you work on pipelines. We call this CI and CD as a pipeline because multiple softwares are getting integrated here, right? So you need to work on the pipeline, whether everything is perfectly there or not. There will be problems. Even after setting up the pipeline integration, there will be problems. You need to fix those issues, right? Okay. So any other questions? If you have any questions, you can ask.
So one guy will be working on Docker, another guy will be working on Kubernetes, and one guy will be creating the code, and another guy will be storing the code on GitHub, which created by some person. So each and different departments, right, sir?
We don't call it as different departments. See, still same department. Everybody will have some idea about different products, but sometimes one person may work more related to that particular product. Yes. Specialized.
Okay, all comes under one roof, DevOps.
Yes.
Okay, sir.
Okay. So any other questions? See, again, I'm saying my aim is to just make you understand what is software development lifecycle, what is DevOps, and why DevOps. What is DevOps? It is a methodology used in enterprises to speed up the. It's a methodology in simple word. And why DevOps? It is to speed up the delivery of the product, right? And in DevOps, a lot of softwares will be used by enterprises, and maybe the people who want to become a DevOps engineer or DevOps person, they need to know various products, but sometimes they don't work on all products. It depends upon enterprise. Okay, but you need to know various products, right? Now, so let's say if you are a beginner and if you are getting started to become a DevOps engineer, maybe in the future, let's say if you are planning to become DevOps engineer in the future, so what knowledge you need to know? I'll just tell about that and I'll finish. Okay. So, see, for sure, you need to know about network fundamentals. Okay. Network fundamentals is very important. You need to know about Linux basics. Okay. Right. And you need to know about cloud. So any cloud, AWS cloud, Azure cloud. Okay. Because in modern day, these softwares which I have mentioned a lot, like Ansible, Kubernetes, Terraform, GitHub Actions, right? These are popular softwares, and these softwares can be used within cloud, within some virtual machines within cloud, or equivalent to these products. Companies like Amazon, Microsoft, they have their own product within cloud. Okay, so if you are not using Kubernetes, equivalent to Kubernetes within AWS cloud, there is a service called EKS, Elastic Kubernetes Service. And within Azure, there is AKS, Azure Kubernetes Service. Have you understood? Sometimes equivalent product will be there, right? So that's the reason maybe as a DevOps person, you need to also have knowledge on cloud. Okay. Then see, there is lots of products. It may be hundreds, thousands of DevOps softwares already there in the market. But as a beginner, sometimes you don't need to know about everything. You can just go with some products in a high level, maybe like Git, GitHub. You can know about Docker, Kubernetes. Ansible, Terraform, and one monitoring tool, for example, Prometheus. Okay, I understood. So if you learn about these things, maybe over the period of time, spending maybe 3 months, 4 months, gradually you are learning everything. Okay, you know how it works. In today, one session, 1 hour, you might have understood what is it. But maybe if you want to create your own CI/CD pipeline, you have to learn a lot. Have you understood? Right. Okay. So any questions? If you have any questions, you can ask, or else we can wind up this session for today. Right. But I'll in the upcoming session, maybe in the upcoming days, I'll plan for some other demo. Okay, today I didn't give any demo. It was completely theory. Maybe in upcoming session, what I can do is I can teach how Git works, how developers use the application code, and how the code is managed, how the code used by the developers are sent to some central repositories. That part I can teach. Then maybe again in some other upcoming webinar, I can teach what is Docker, right? How it is used in enterprise by both developers and operations, right? So we can plan like that. Okay. Yeah, if you have any questions, you can ask, or else, yeah, we'll finish with this.
Thank you very much.